Let us look at proposition number 2 of book 13 of Euclid's Elements. The proposition says that if the square on a straight line is 5 times the square on a segment on it, then when the double of the said segment is cut in extreme and mean ratio, the greater segment is the remaining part of the original straight line. So this is basically the converse of the previous proposition. Let the square on AB be 5 times the square on AC, and let CD be 2 times AC. Then what the proposition is saying is that when CD is cut in extreme and mean ratio, then the greater segment is the segment BC. Let's proceed. Construct the square AF on AB. Now we construct the square CG on CD. So here the square on AB is equal to 5 times the square on AC. So let's take care of that. Here what I have done is I have extended KC to Q. I have drawn the diagonal AF. I have marked the intersection of QC with AF as H, and I have drawn PH parallel to AB. And then I have extended FB to E. I have not done it, so I'll do it now. Now, AF is equal to 5 times AH. How? Because AB square on AB is nothing but AF. And square on AC is AH. We have AF is equal to 5 times AH. That means the gnomon MNO. So let me draw the MNO. Gnomon MNO is equal to 4 times AH. Since gnomon MNO is AF minus AH. Again, we are given that CD is equal to 2 times AC. That means square on CD is equal to 4 times the square on AC. Square on CD is CG. Square on AC is AH. So CG is equal to 4 times AH. That means gnomon MNO is equal to CG. Because gnomon MNO is equal to 4 times AH, CG is also 4 times AH. CD is equal to 2 times AC, CD is equal to CK, and AC is equal to CH. So we can say CK is equal to 2 times CH. So that means KB is equal to 2 times BH. How? Because these two parallelograms, that is KB and BH, they are between the same parallel lines. So that means they are proportional to their bases. LH plus BH is equal to 2 times BH because LH and BH are equal. KB is equal to LH plus BH. How? Because again KB is 2 times BH, but 2 times BH is nothing but LH plus BH. So KB is equal to LH plus BH, and we know gnomon MNO is equal to CG. So gnomon MNO minus LH plus BH. So what does it give us? Gnomon MNO minus LH plus BH gives us FH is equal to CG minus KB. So we have HF is equal to BG. How did we get this? Because gnomon MNO minus LH plus BH gives us HF. and CG minus KB gives us BG. And BG is the rectangle DG by BD. But DG is equal to CD, so we can say BG is equal to rectangle CD by BD. Now what is HF? HF is the square on BC. So now we can say BC square is equal to rectangle CD by BD. Why? Because we saw that HF equal to BG, HF is BC square, and BG is rectangle CD by BD. So BC square is equal to rectangle CD by BD. Do you notice BC square is equal to CD by BD basically means that we have a proportion, that is CD is to BC as BC is to BD. And since CD is greater than BC, implies BC is also greater than BD. So that means when CD is cut in extreme and mean ratio, so CD has been cut in mean ratio at B, and as the proposition says, the greater segment is BC. So we have proved what was required. Now, as part of this proposition, a lemma is also included, where we show how we can say that 2 times AC is greater than BC. So again, proof by contradiction. If possible, let 2 times AC be equal to BC. Squaring both the sides, we get BC square is equal to 4 times AC square. So BC square is equal to 4 times AC square. BC square plus AC square is equal to 5 times AC square. How did we get this? We have BC square equal to 4 times AC square. So basically we are adding AC square to both the sides, so that this becomes 5 times AC square and this becomes BC square plus AC square. AB square, we are given that it is 5 times AC square. So that means AB square is equal to BC square plus AC square, which is impossible, since we know that if a point cuts a straight line randomly, then the square on that line is equal to the square on one segment plus the square on second segment plus 2 times both the segments, or 2 times the rectangle BC by AC. So because of this impossibility, we can say BC is not equal to 2 times AC. Similarly, we can show that a straight line less than BC is also not equal to 2 times AC. So that means 2 times AC is greater than BC. So that is proposition number 2 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.